Welcome to this video where we show how you could do time series anomaly detection in mainframe performance metrics. I've collaborated with my colleague Q Kim on this video. Quickly, we're going to show unsupervised learning, which we're going to simplify to mean clustering, where instead of having marked data, we have just data that we use various techniques shown here, k-means, SVM, and isolation forest, to algorithmically find the groupings of data. The data flow that we're going to show is OMEGAMON, the CICS service level analysis workspace data. We collect that off a REST API into a CSV, import that CSV into a Python notebook where we're using SciKit-Learn, and then we do 3 styles of clustering in that notebook. A quick peek at what the data looks like coming from OMEGAMON for CICS. Here is a brief output of the CSV data. A lot of zeros, but also a lot of interesting information. And we zero in on the response time for transactions. Here's a quick run through of our Python Jupyter notebook. We're using pandas data frames. We read in our dataset CSV into a data frame, display some basic information to make sure we got that data frame just the way we expected it. You can see the various CICS columns shown here: total transactions, response time, average CPU, DB2 wait, redispatch wait, and then a quick look at various statistics for those metrics, and more manipulation and investigation of the data frame. Finally, a visualization of that time series data set. Then we move into k-mean clustering, and quickly we see in the elbow curve it looks like there's roughly 7 clusters of data here in this data frame. Proceed to do the manipulations for k-means. We find 9 outliers or anomalies out of the 199 data points. And here's the graph with the red dots showing the 9 points, but not too satisfying, because we as humans see more than the clustering is seeing. So we move on to support vector machines, a little more satisfying here. And finally, we move to isolation forest, perhaps the most satisfying. So that's it. That's how far clustering can take us as far as time series anomaly identification. You'll see there's a gap in the data, which is another interesting anomaly that clustering doesn't really help us so much with. And another person might say, well, I only see one critical anomaly in this data. Maybe these other anomalies are not as important in the overall scheme of things. But that's it. Thanks for watching.